Christine Fitzgerald from Perfect Squares Tutoring. Today's question says factorise, firstly 4a squared b plus 7abc, take 12ac, take 21c squared. And secondly, factorise 18x squared, take 27x plus 10. So a bit of practice at our factorising skills. Okay, the first one has 4 terms. So I'll write it out again. And the first thing we check for when we're factorising is a common factor across all terms. So A and B, A, but no, there's nothing that goes into every single term. So I can't take out a common factor. But there's 4 terms. And one method of factorising which uses 4 terms is a method called grouping in pairs. So at the moment that's the only idea I've got. We'll try it and hope that it works. Now what you do with grouping in pairs suggests that you work with 2 terms at a time. So if I look just at the first 2 terms, 4a squared b plus 7abc, and remove a common factor from those, it would be AB. Divide AB out of here, we're left with 4A. Divide AB out of this term, we're left with 7C. So I've factorised the first 2 terms. Now look at the last 2 terms. I can take out a negative 3C. Negative 3C is the common factor. And what's left, if I take out the negative, what's left will be positive. There's a 4 and an A. And here it's also positive, 7 and another C. For grouping in pairs to work, you need your brackets to be the same. And they are. Okay, so that worked well. If it doesn't work out that way, all I can suggest with 4 terms is that you reorder the terms in the original question and see if that helps you get your 2 brackets the same. Because sometimes the terms are just given in the wrong order. Okay, so now I'm going to factorise the common bracket out. 4a plus 7c is common to both these 2 sections. And what's left is AB from here and negative 3c from here. So that's the factorised version. AB take 3c by 4a plus 7c. Now for part B, factorise 18x squared take 27x plus 10. It looks like a more normal factorising where we want 2 brackets and the numbers we choose multiply to this and add to this. But not when we've got a number other than 1 here in front of the x squared term. So there's a couple of methods you can use to approach this. I'll show you my preferred way, but there's another one which works. It's sometimes known as chopsticks or crisscross method. So if you've got your own technique, that's okay, but if you haven't, feel free to learn this way. What I do is I copy down the first term and I copy down the last term. And then, as I said, I would normally go looking for 2 numbers that multiply to the 10 and add to the negative 7. But no, I want 2 numbers that multiply to 10 times 18. So they in fact need to multiply to 180, but still add to negative 27. Okay, so if you think up 2 numbers that do that, multiply to 180 and add to negative 27, I think you're doing very well. It's not that easy to find because the numbers are big. So I'll show you how you can systematically find them. Let's find as many factors as we possibly can of 180. Does 1 go in? Yes. 1 times 180. Does 2 go in? Yes. 2 times 90. Does 3 go in? Yes. 3 times 60. 4? Yes. 4 times 45. Does 5 go into 180? Yes, that's a factor. 5 times 36. Does 6 go in? Yes. It'll be like this. It must be 6 times 30. Does 7 go into 180? No, it doesn't. Does 8 go into 180? No, it doesn't, because 4 goes in times an odd number, so 8 won't go in evenly. Does 9 go in? Yes, 9 times 20. And you've got to keep going. You've got to check every single number starting from 1 until there's no more, and I'll show you when there's no more. Does 10 go into 180? Yes. 10 times 18. Does 11 go into 180? No, it doesn't. Does 12 go into 180? Yes, it does. 12 times 15. Does 13 go in? No. Does 14 go in? Well, 7 didn't, so 14 certainly won't. Does 15 go into 180? Yes, it does. And I've already found it. So because I'm asking for something by checking every number since 1, and I've already got it, I know that I've finished. Because, what about 16 and 17 after that? Well, if they were factors, they would have come up in between here. And I checked everything in between 10 and 12, so I know for certain that I've got every whole number factor. Okay, so they're my options. And look, you might come across it really early in the piece and you wouldn't even have to finish the job off. But I've shown you the whole thing for today. Now, I want them to add to negative 27. They multiply to a positive, so the signs are the same. They add to a negative, so the signs are both negative. And they are, in fact, 12 and 15 is the pair of numbers there that adds to 27. So if I make them both negative, they'll now still multiply to positive 180, but they will add to negative 27. So I put them up here, the negative 12 and the negative 15. It doesn't matter which one comes first, but they get an X on them. It's the only thing you really have to remember. Put an X on. And now we've got 4 terms, so we group in pairs. Look at the first 2 terms. Common factor is 6x. Look at the second 2 terms. Common factor is negative 5. Just because the first number is negative, I will take that negative out. And that goes in 3x and 2. Now, of course, our brackets are the same. If this works for us, if we're able to find the numbers, the brackets will be the same. So the factorised version is 6x take 5 by 3x take 2.